So what we are doing today is extremely similar to what we just got done doing, what we did on Tuesday. Big difference is we're not going to have a 1x squared. We're going to have something else in front. But the process will remain the same. Please ignore this box. We're not going to use box. We are going to use the x, however. And the process works the same. So we're not going to do the box, but pretty much everything is almost exactly the same. So first thing we do is fill in the x at the top. Do the same thing. You multiply the first number and the last number. Now, what we're doing Tuesday, it was 1 times whatever, so it's just the last number. You multiply them. I get 6. And then the middle number here is what goes in the bottom. It's still 2 numbers that multiply to give me that add to give me that. Once again, you can, if you need to, and you can use the sheet we did the other day to list your pairs of factors. Which one? Multiples of 6, add up to give me 5. 2 and 3. So I'm going to put 2 here, and I'm going to put, actually I'm going to put 3 on this side. There's a reason for that. No, I'm right. 2 here and 3 here. Doesn't really matter. You have enough room. I'm a little tight on room on this one. Now, when we were doing this on Tuesday, we divided both sides by 1x because we had 1x, but we don't have 1x here. How many x? What do we have here? We have a 3. So we're going to divide both of these by 3x. Now, before we get our final answer, because this will be the same thing, bottom and front, top and back. However, if we have a fraction that can be reduced, we reduce. Can I reduce 2 over 3? No, 2 over 3 can't be reduced. 2/3 cannot be reduced. Can I reduce 3 over 3? Yeah, what are they both divisible by? 3, right? So if I reduce this, divide them both by 3, I get 1 over x. These give me my factors. This is my first factor. Bottom and front, top and back, 3x plus 2. My reduced fraction, 1 over x, does the same thing. Bottom and front, top and back, x plus 1.
If you don't reduce the fraction, it will not be the correct
No,
factor.
you absolutely have to reduce any fractions you get. And just about all of them will be reducible. I don't think there are any that aren't. Okay. Almost exactly the same thing that we did on Tuesday. Almost. A couple little important tweaks to what we were doing on Tuesday. First thing you do when you have these, set up your x. Now, I would strongly suggest you don't put your x too far close to the edge of the paper. Leave yourself some room. And then fill in the top and the bottom. Remember, multiply the numbers on the outside. So I have 5 times 2, that gives me 10 on top. And then I have 11 on the bottom. 2 numbers that multiply to give me 10, then add to give me 11. 10 and 1. This is probably one of the most difficult problems for students to get, because they think, oh, 10, 2 times 5. But wait, 2 times 5 is not 11. And they don't think about 1 in the number. That's why when we were doing on Tuesday, I did the multiple list. I had you do 1 in the number every single time, because that is the most commonly screwed up one, is when it's 1 in that number. So I have 1 and I have 10. 1 times 10 is 10. 1 plus 10 is 11. And then what goes on the bottom? I divide these both by what? What goes on the bottom of these ones? 5x. I have a 5 in front, so I put a 5x on there. Can I reduce 1 over 5? No. Can I reduce 10 over 5? Yeah, I can reduce 10 over 5. What are they both divisible by? 5. Divide them both by 5. That gives me 2 over x. Always reduce. You have to reduce. If you don't try to reduce, it's not going to have the right answer. So what do I have here? I have 5x plus 1, bottom and front, top and back. And then my other factor comes from this, bottom and front, x, top and back, plus 2. 5x plus 1 times x plus 2. Now I can tell you, doing this with the x is so much easier than what we used to do. It used to be guess and check and guess and check and guess and check. This is so much easier.
Does it matter if the 10 to the 1 is and the 1 is?
No, it does not. Because if you put the 10 on this side and the 1, if you put the 10 over here and the 1 over here, you would still get the same 2 factors. It's just this side would reduce and that side wouldn't. So you'd still get the same 2 factors in the end. Okay, same thing. What goes on the top? 14. 7 times 2 gives me 14. What goes on the bottom? 9. 2 numbers that multiply to give me 14 that add to give me 9. 7 and 2. And it doesn't matter which side they go on, just that you have those 2 numbers. What am I going to divide them by? What do I have here? I have a 7m, so I divide both sides by 7m. Can I reduce this? Yeah, 7 and 7, they're both divisible by 7. This equals 1 over m. That's one of my factors. Can I reduce 2 over 7m? No, so this is my other factor. So I have m on the bottom, 1 in top, so I have m plus 1. And then my other factor is 7m plus 2. Piece of cake, right? Like I said, for years, I did not teach this because I did not know this and I didn't learn it this way. Nobody showed me. Once I got on, like, holy crap, this is so much easier. So much easier. Okay, so far these have all been pretty easy. Let's keep going. What's on top? What goes up in the top here? 30. 6 times 5. 30. What goes on the bottom here?
13.
13. So I have to have 2 numbers multiply to give me 30, then add to give me 13. Remember, if you don't know it, you can always say, hey, what are my factors? And 5 and 6. 1 and 30, 2 and 15, 3 and 10, 5 and 6. Which ones add up to 13? Yeah, 3 and the 10. List the factor pairs. And a lot of these numbers you're dealing with are ones that are on the sheet we did on Tuesday. So I have 3 and 10. What do I have up here? I have a 6. So what do I have underneath? 6x. And then I try to reduce if I can. Can I reduce this? Does 3 over 6 reduce?
No.
Yeah, they're both divisible by 3, right? So I end up getting 1 over 2x. So there's one factor. What about this side? 6 over 10. Is that reducible? Yeah, they're both even, right? So they're both divisible by 2. Divide them both by 2, I get 5 over 3x. Sometimes both of them are reducible. That happens. Sometimes they're both reducible. Not a big deal. Just means that I have 2x plus 1 and 3x plus 5. Questions? Okay, uno más. A little bit more difficult, but not too bad. What goes on the top?
You need to wait. Okay.
Yeah, you can wait a minute. Okay. What goes on the top? 60 or negative 60. Watch your signs. I've got a negative 15. Negative 60. Be careful on that. What goes on the bottom? 17. So this one's a little trickier because I'm looking for two numbers that multiply to give me 60 that subtract to give me 17. 162, 33, 24, 15, 5, 12, 6, and 10. Man, there's a lot of combinations that give me 60. Which ones of those would I subtract to get? Yeah, 3 and 20. Okay, so I'm going to have 3, and I'm going to have 20. And I'm going to erase this because I need room. Now, which one's negative and which one's positive? Which one's negative? The 3. Here's a hint. What sign is this number down here? Positive. Whatever this is, your larger of these two numbers is going to be. This is positive. My larger factor is going to be positive. That means that one's going to be negative. And if you want to, you can check it. Negative 3 times 20 gives me 60. Negative 3 plus 20 gives me 17. What am I going to put underneath? 4K. Does negative 3 over 4, does that reduce? No, so this one's good. What about 20 over 4? Yeah, they're both divisible by 5, so I get, by 4. So I get 5 over K. So my answer is 4K minus 3 and K plus 5. You will always have at least one fraction that reduces. You might have both, but you will have at least one that reduces. You might have two, but you will have at least a minimum of one. So always check that. If it doesn't reduce, you did something wrong. And if you don't reduce it, you will have the wrong answer. We're going to do a skill test today, and the skill test today is doing these. Okay, so you absolutely need to make sure that you're getting them right. We'll do some practice first, but you will do these for your skill test. Questions?